Okay, so we're going to talk about Chapter 3. Chapter 3 is talking about forces, and the first force we're going to talk about is Newton's second law of motion. Now remember, Newton's first law of motion states that an object will keep moving unless acted on by outside forces. Newton's second law of motion is known as the law of acceleration. And basically it's saying that an object will accelerate in direct proportion to its net force and inversely to its mass. And so we can use the equation that can go onto your equation sheet is force is equal to mass times acceleration. Remember, force is always measured in newtons, mass is in kilograms, and acceleration is meters per second squared. And so here is Newton's first law kind of written out in formula form. And so we have A is equal to force over mass, which can also be written as force is equal to mass times acceleration. And remember, 1 Newton is equal to 1 kilogram times meters per second squared. And so all of this stuff right here can go on to your equation sheet as like a little reminder and assistance in how we can solve for these problems, which we'll do just a little later on in this. Okay, force and acceleration. So what's the difference about throwing a ball horizontally as hard as you can and tossing it gently? Well, when you throw a ball, such as in baseball or softball, you are trying to throw it as hard as you can, and you throw with a greater force. And because you're throwing with a greater force, then it will have a greater acceleration. If you throw with less force, it'll have less acceleration. And so the harder you throw, the greater you have in the change in velocity. Remember, velocity is not only its speed, but also the direction it's going. And so because you're throwing with a greater velocity, it takes a shorter time, and so it will also therefore have a greater acceleration rate because velocity is divided by time to get acceleration. Now, if you can throw a softball and a baseball as hard as you can, why don't they have the same speed? Well, think about this. Which one's bigger, a softball or a baseball? Why would they have different speeds? You can pause this right now and kind of answer that question. And so the reason we're going to have different ones is due to their mass. And so if it has a greater mass, such as the softball, you're going to throw with a different force, and therefore it's going to have a different acceleration rate based on that. And so Newton's second law, the acceleration depends not only on the mass, but as well as the force exerted on that. And so that's why we have to use mass and acceleration to calculate the force of that object. Think about this. Gravity is something that acts on everything. And so when we have gravity and something's falling to the ground, it will fall with more force if it is higher in mass. So if we have a bowling ball and we have a tennis ball, they're both going to hit the ground at the same time. They're both pulled at the same acceleration rates, but the bowling ball is going to leave an indent and the tennis ball is going to bounce. And that's because it's hitting the ground with more force. Something that can act on this is known as friction. And so friction is basically a push or a pull on an object. So suppose you're on a skateboard and you push it with your hand. According to Newton's first law of motion, as long as there's nothing acting on that object, rate equals 0, it continue moving in a straight line with a constant speed. But does it? No. And the reason it doesn't is because of friction. Okay, so recall that when you have an object that slows down, it has a negative acceleration rate, and then an object that speeds up has a positive acceleration rate. So if an object is slowing down, it's happening because of Newton's second law, and that therefore there must be some type of force acting on that object to change that acceleration rate, and it's going against Newton's first law of motion. And so the force that will slow the skateboard down and bring it to a complete stop is really friction. And in this case, it would be rolling friction. Okay, so what is friction? Friction is the force that opposes motion between the surfaces that it touches and you can have different types of friction depending on how the surfaces are touching. So two surfaces will have like a contact force, will be a welding or a sticking that occurs where the bumps touch each other. And so these micro welds are a source of friction, and they don't really want to let anything go past each other. They kind of stick as things go by. And so the larger the force pushing on the two surfaces, the stronger these micro welds can be. And so the problem being is when you have these micro welds or these sticky portions, they don't go past each other, and it can cause a lot of tension or not allow an object to move at all, which can become an issue. The two move one surface over the other, the force must be applied to break the micro weld. So you have to have more force being applied to that than what the micro weld is actually holding. And so you can see here, if we don't have that force, those micro welds or those contacts will like not let anything move. And if you don't have that, then we have what we call static friction. And so suppose you have filled a cardboard box with books and you want to move it. It is too heavy to lift, so you start to push it. Does it budge? So I want you to answer that question. You can pause the video right now. Does it? But it doesn't budge. Okay, so why? Well, it's because those micro welds are holding it there. It's got a static friction, so it's actually going in the opposite direction. So it'll have a zero acceleration rate. Even though you're applying force to it, it's not moving. And so what type of force would this be acting on the object? We learned this from last chapter. You can go ahead and answer that now. Sorry, went backwards for a second. Okay, so according to Newton's second law, if the acceleration rate is zero, then the box won't move and it won't cancel out. And you guys should have known from last chapter that this is a balanced force and it's not moving. And so we don't see an unbalanced force when it actually would move. So static friction is a result of a balanced force. And so the forces of friction due to these micro welds at the bottom of the box, it just won't allow anything to move at all. And so then we have sliding friction. So if you ask your friend to help move the box and you push it together, hopefully you have enough force that it will overcome and break these micro welds, and you are applying a greater force in the opposite direction, which would be an unbalanced force. And if you're able to move the box. If you stop pushing, the box quickly will come to a stop because obviously the micro welds are going to be there and they're going to stop the box from moving. And it is an opposite frictional force on the floor, which is overcoming what you were actually pushing at. It's sliding friction because you're sliding it across the surface. And because you're able to break those micro welds, those surfaces are able to pass one another. Another good example of sliding friction is if you rub your hands together back and forth really quick. One of the things that forms because of sliding friction, which is kind of an energy, because you're using kinetic energy to move your hands back and forth and create that sliding friction, heat is also another example. So whenever you have frictional forces, heat is a byproduct of that. Something else that we have to remember when we talk about this is our gravity. Okay, so what is gravity? Gravity is the force that acts between any two objects in a universe. It increases as the mass increases or the distance decreases. So, who experiences gravity more, the astronaut or here are politicians? So, first off, you have less distance, so our politician is going to feel the gravitational pull more than the astronaut. Which is exerting more gravity, the Earth or the Moon? Well, if they're equal distances, well, which object's larger? You can go ahead and answer these questions really quick. The answer to this would be the Earth is exerting more because the Earth has more mass than the Moon, and so it would have a greater pull on the astronaut. So you can write this equation onto your chart as well. Weight is equal to mass times acceleration. Well, weight's a force. So really, it's Newton's second law is your weight. Now, when we use our scales to measure mass, they're actually taking out gravity. So we're actually in a mass weight. When you step on a scale and you're measuring pounds, that's actually taking gravity into account as well. So you have to be careful about that. Weight and mass are not the same thing. Weight is your mass times your gravity. Now remember, gravity due to acceleration is 9.81 meters per second squared. And if you go to a different planet, which one would you weigh more on, Earth or Jupiter? You can go ahead and answer that question right now in your groups. You can pause the video to answer that. And so it's Jupiter. And the reason it's Jupiter is because Jupiter has a greater mass, much greater mass, which equals greater gravity, which would then equal greater weight for you. And so gravity due to acceleration. So we have an elephant here and you have a little bug and they're both dropping. Which one is going to hit the ground first, the elephant or the bug? They're dropping at the same height. Which one will hit first? Well, they're both falling with the same acceleration rate of 9.81 meters per second. And so really, if we drop that, sorry, it's a feather, not a bug. Gravity is the same. So unless air resistance is acting on the feather, which is not acting on the elephant, they'll fall and hit at the same time. Now we know that air resistance, which we'll talk about in a second, is acting on the feather, which doesn't allow for it to drop at the same time. You can do an example in class. If you hold a textbook and a piece of crumpled paper up at the same height, and you drop them, they'll hit the ground at the same time. If you want to try that, you can sure try that. However, if you take that same concept and you have a textbook and you have a flat, just regular sheet of notebook paper, the textbook's going to hit before the notebook paper because air resistance is acting on that. So let's talk about air resistance a little bit. Air resistance is known as fluid friction or drag. It is a force that is exerted on a moving object opposite to its motion. It depends on speed, surface area, shape, and density of a fluid or density of the object. So those are all things that will act on air resistance. And so here we have a picture of a guy in a parachute. The parachute is very lightweight material. It has a greater surface area. It's actually catching air and pushing an upward force, even though gravity is pulling the guy down. And so what we're trying not to reach a terminal velocity. This is the maximum velocity of a falling object. So when force of gravity is equal to force of air. And so we can see here that we have an upward force of the air and a downward force of gravity, which slows it down. Which is why when you jump with a parachute, you actually jump and don't hit the ground quite as fast as if you fall without a parachute. And so in this case, because they're equal, there is no net force. It means there's no acceleration, and it has a constant velocity. So you're falling, but you're falling slowly, which is kind of a good thing. Okay, we're going to pause this and we're going to talk about terminal velocity in just a second. We have to go to part 2 of the tape because the video is going to run out.